Johann Carl Friedrich Gauss is one of the greatest and famous mathematicians to have existed in the 19th century. He was sometimes referred to as the Prince of Mathematics or the foremost of mathematicians. He was the first to prove the fundamental theorem of algebra, which states that every polynomial equation has at least one root, that is, a complex number. He also derived the functional representation of the normal distribution. Carl was born on 30th April 1777 in Brunswick, which is now part of Germany. His parents were poor working-class citizens. It is known that his date of birth wasn't recorded because his mother was an illiterate. She only knew that Carl was born on Wednesday, 8 days before the Feast of Ascension, which occurs 40 days after Easter. Carl derived a method to calculate the date of Easter in any year and was then able to figure out his own date of birth. The clever little guy. As a child prodigy, he is said to have corrected an error in his father's payroll calculation as a small boy of 3. Carl got to elementary school in 1784. His elementary school teacher, Bethany, posed a question to the class to find the sum of integers from 1 to 100, and he, at the age of 7, was able to solve it as soon as the question was presented by multiplying 100 by 101 and then dividing it by 2. This facilitated the development of a formula to find the sum of terms in arithmetic progression. With the support of his elementary school teacher, Johann Martin Bartels, assistant to Bethner Gauss, went on to attend senior secondary school in 1788, where he studied language. Bartels' acquaintance to influential men of Brunswick led to Gauss being brought to the attention of Karl Wilhelm Ferdinand, the Duke of Brunswick, who provided him funding to attend university. He went to College of Carolinum in Brunswick from 1792 to 1795, during which the Duke subsidized a 2-year course at Gymnasium. He afterward went to University of Göttingen from 1795 to 1798. In 1796, Gauss advanced modulo arithmetic, which simplified manipulations in number theory. He was the first to prove the quadratic reciprocity law, which determines the solvability of any quadratic equation in modular arithmetic. He discovered that every positive integer is representable as a sum of at most 3 triangular numbers. He showed that a regular polygon can be constructed by a compass and a straight edge if the number of each side is the product of distinct Vermont primes and a power of 2. At this stage, Carl's attraction to philological studies was overcome by a more compelling attraction in mathematics. He also completed his writings of a fundamental work in number theory, which was officially published in 1801, titled Arithmetic Investigations. With the help of Professor Johann Friedrich Pfaff, made it easier to do his dissertation and ultimately get his PhD in the University of Hampstead. In 1809, Gauss published his second book titled Theory of the Motion of the Heavenly Bodies Surrounding the Sun in Conic Sections. This helped in the discussion of conic sections and elliptic orbits. He focused heavily on astronomy and found time to work on other things such as general investigation of curved surfaces and introduced the hypergeometric function. He also helped introduce non-Euclidean geometry. Besides the before mentioned, he has had remarkable contributions in many fields of mathematics. Unfortunately, it is very hard to explain all of them in one video. Some of these contributions are